The survival function defines the probability that the event of interest has not occurred at time t. It can also be interpreted as the probability of survival after time t. Here, t is the random lifetime taken from the population and it cannot be negative. Note that the survival of time t is between 0 and 1, where 1 is inclusive and it is a non-increasing function of time t. The hazard function, also called the intensity function, is defined as the probability that the subject will experience an event of interest within a small time interval, provided that the individual has survived until the beginning of that interval. It can be thought of as the instantaneous rate calculated over some time period, and this rate is considered constant. It can also be considered as the risk of experiencing the event of interest at time t. It is the number of subjects experiencing an event in the interval beginning at time t divided by the product of the number of subjects surviving at time t and the width of the time interval. Since the probability of a continuous random variable to equal a particular value is 0, that's why we consider the probability of the event happening at a particular interval of time from time t till time t plus delta t. Since our goal is to find the risk of an event and we don't want the risk to get bigger as the time interval delta t gets bigger. Thus, to adjust for that, we divide the equation by delta t. This scales the equation by delta t. The equation of the hazard rate is given here. The limit delta t approaches 0 implies that our goal is to measure the risk of an event happening at a particular point in time. So taking the limit delta t approaches 0 yields an infinitesimally small period of time. One thing to point out here is that the hazard is not a probability. This is because even though we have the probability in the numerator, but the delta t in the denominator could result in a value which is greater than 1.